A new AI giant might have just been born. Today, we're going to break down the technical report for a new vision language model that's making some serious waves. So let's get right into it.
Okay, so what we're looking at here is the technical report for Qwen 2.5-VL. This is the latest flagship model from Alibaba's Qwen team. And listen, they are making some really big claims. We're talking about a model that can see, understand, and even act in our digital world in ways we haven't seen before.
So the story here really is about a new challenger. You've got this open source model, right, available to literally everyone, stepping into the ring to take on the biggest, most well-known proprietary names in AI. It's kind of like a David versus Goliath situation.
And that right there brings us to this central question, doesn't it? Could an open source AI, something anyone can access, really challenge giants like GPT-4o and the brand new Claude 3.5? I mean, is that even possible? Well, let's dive into the report and see what the evidence actually says.
Okay, so to really get why this model is such a potential breakthrough, we first have to understand the problem it's trying to solve. And the report uses this really simple but powerful analogy for it. They call it the sandwich cookie problem. So the Qwen team's argument is this. Think about today's most powerful AIs. They're like the creamy filling in the middle of a sandwich cookie. They're really competent at a lot of different tasks, but they're missing the top and bottom cookie layers. They don't have that deep foundational perception on one side or that high-level reasoning on the other.
So, what are those missing cookie layers? Well, the report points to some pretty specific bottlenecks. For one, these models struggle with tiny visual details. They have a limited grasp of the bigger context. They're also computationally super expensive to run, and honestly, their performance can be all over the place depending on what you give them. This is the foundation that Qwen 2.5-VL was built to fix.
So, the big question is, how did they pull it off? Let's pop the hood, go inside the engine, and check out the key technical innovations that are really powering this thing.
Whoa. Okay, I know what you're thinking. This diagram looks intense. But don't worry, we are absolutely not going through every single box and arrow here. Think of this as the model's blueprint. We're just going to pull out the 3 most important innovations that you really need to know about.
All right, innovation number 1. How does he incredible detail without, setting your computer on fire? See, traditional AIs try to look at a whole high-res image at once, and that is just computationally brutal. It's super slow. What Qwen does is use something called window attention. It's smarter. It focuses on smaller patches of the image one at a time, which lets it process way more detail, way more efficiently.
Next up, and this one is crucial for understanding the real world, is native dynamic inputs. What this means is the model sees images and videos exactly as they are, in their original size, their original aspect ratio, their original frame rate. So no more of that awkward stretching or cropping that just throws away vital information. It's basically seeing the world without a funhouse mirror effect. And then there's the problem of understanding time. For this, they came up with a really clever new technique called absolute time encoding. The simplest way to think about it is that it syncs the AI's internal clock with the actual timestamps of a video. This is huge because it means the AI understands not just what happened, but precisely when it happened. We're talking down to the second, even in super long video.
Okay, so that's the theory, right? A more efficient, more detail-oriented, and time-aware architecture. Sounds great on paper. But does it actually work? Does it deliver? Let's get to the fun part and look at the test results. Let's see the proof in the numbers.
First off, just to set the stage, let's talk about the sheer scale of the training here. The model was pre-trained on a staggering, get this, 4.1 trillion tokens of data. That's with the T. That just gives it this immense foundation of knowledge to draw from for pretty much any task you can think of.
So with all that training, what are the results? Well, these radar charts give us a fantastic bird's-eye view. Qwen's performance is that purple line, and as you can see, it's pretty much always pushing the outer edge of the chart across dozens of different benchmarks. That means it's either matching or, in a lot of cases, actually surpassing the top-tier models like GPT-4o and Claude 3.5.
Okay, let's drill down into a specific area, like document understanding. On this particular test, the doc-VQA test, Qwen hits a 96.4, which puts it in a clear lead. What that really means is it has a superior ability to read and pull information out of messy, complex stuff like forms, tables, and reports. All right, next up is a really tough one, visual math reasoning. This is where you show the AI a chart or a diagram and ask it to solve a math problem based on what it sees. And once again, Qwen posts the leading score, 74.8. That's a pretty significant jump over the competition.
Hey, remember that absolute time encoding we talked about? Well, this is where we see it pay off. Big time. On a task called video grounding, which is basically asking the AI to find the exact moment something happens in a video, Qwen scores a 50.9. GPT-4o, it's way back at 35.7. I mean, that is a massive, massive performance gap.
And what's really important here is that it didn't get these amazing vision skills by giving up its language abilities. The report shows that even on pure text benchmarks, Q25VL is still performing right there at the top of the pack, hanging with the best text-only models. It's a true all-arounder.
Okay, so benchmark scores are great, but what does all of this actually mean in the real world? Why should you care? Well, it's all building towards something incredibly practical, a powerful visual agent.
See, the ultimate goal here isn't just about answering what's in this picture, it's about creating an AI that can actually understand and interact with your computer screen or your phone screen, just like a person would. An AI that sees what you see and can then do things for you. So what does that look like in practice? Well, it translates to some incredible new skills. We're talking about precise object grounding, so knowing exactly where that confirm button is so it can click it. It means reading any text on any screen, from an app to a website. It means understanding really complex user interfaces and even executing multi-step tasks on your device, all by itself.
And here is the big payoff. This chart shows how well these models do on a test where they have to actually control an Android phone to complete tasks. Look at this. GPT-4o scores just under 21. Qwen 2.5VL, over 67. That's not just a lead, that is a game-changing, more than 3 times better performance in the race to build AI agents that are actually useful.
So when you put it all together, what does this mean? Look, Q 2.5-VL isn't just another incremental update. The technical report really positions this as a major leap forward, a step towards an AI that can finally perceive, understand, and, most importantly, act within our visual, digital world.
And all of this leaves us with one final and, I think, really fascinating question. This tech is incredibly powerful, and because it's open source, it's going to be in the hands of developers and creators everywhere. So it makes you wonder, what will you build when your AI can finally, truly see and act?